Today, let's get started with Kubernetes. Kubernetes is also container orchestrator tool. Like we have already learned one tool in this category. What is that tool?
Docker.
Docker.
Docker Swarm, not Docker. Docker Swarm is another container orchestrator tool. It's a product from Docker. Whereas Kubernetes is also a container orchestrator tool. This is a product from Google. And initially, it's a product from Google, basically developed and it's a product from Google, but now it's managed and maintained by CNCF, Cloud Native Computing Foundation. So, yeah, these are all container orchestrated tools. There is one more tool which falls under this category like Mesos. This is from Apache. It's a product of Apache, but out of all this, Kubernetes is very widely used and very famous and advanced and extensively used tool. It has got advanced, far advanced features when you compare with any other tool. So we will be learning about Kubernetes here. So before we get into Kubernetes, let's analyze few differences between Swarm and Kubernetes. Both are container orchestrated tools. Like we have learned, container orchestration means managing the containers. Managing means again maintaining their high availability, scaling them, load balancing of containers across the cluster, rolling updates, rollbacks, and so many. Both does the same, but Swarm is not efficient, or we cannot rely on Swarm for 100% or else zero downtime. Whereas Kubernetes promise zero downtime. Apart from this, there are differences like Swarm is very easy to learn and very easy to use. Whereas Kubernetes is a completely a different tool, we can say, right? Complex setup as well. And Swarm commands are almost same like Docker commands, right? But here commands would be completely different. And Swarm setup is also very simple. Of course, we did not set up Swarm at all. Do you remember? Have we installed Swarm? How did we start Swarm? We did not install it. If you remember, we just have initialized using Docker Swarm. But here, yes, you have to do the setup. And the setup varies from environment to environment and platform. Like you have a different setup on your on-prem clusters, you have different setup on cloud, on AWS, on GCP, and so on. So setup is different. Yeah, Swarm is easy to set up. That's not the case with Kubernetes. And what else? Yeah, architecture is also totally different. You will learn the architectural differences when we actually get into it, because you see different components in Kubernetes. And what else? And another main difference is Swarm can manage, orchestrate only Docker containers, whereas Kubernetes can orchestrate containers from any runtime. We have learned, if you remember in the beginning, there were different container runtimes, right? Like Docker, Rocket, LXC, OCI containers, and so on. So many are there. But of course, Docker is very famous. Swarm can orchestrate only Docker containers, whereas Kubernetes can orchestrate containers from any runtime. That is another major difference. Also in Swarm, yeah, you can write, like you will write a single line commands to deploy or do any task, right? In Kubernetes, we prefer declarative approach. This is the best method in Kubernetes. And Kubernetes files, or which are called manifest files, are written in YAML or JSON, right? Those are some of the differences. And like I said, Swarm, you cannot do automatic scaling. You have to scale them by providing the number, but automatic scaling is possible here in Kubernetes. You have automatic scaling here. Automatic scaling not available. You may have to write additional scripts for it, but here automatic scaling is possible, right? And also can't promise zero downtime here. For applications, no zero downtime. Kubernetes can help you achieve zero downtime for applications, right? These are few other differences you have. So to understand this better, let's get into the architecture of Kubernetes, understand the components. That helps us a lot. Can we go ahead? Any questions on this part?
Yes, Preeti, we can continue.
Yeah. We'll get into the architecture now. Yeah. So here is the architectural diagram for Kubernetes, if you see. Yes. Okay. So here, if you see, like we were talking about in Swarm, here also we have a Kubernetes cluster. It's a bunch of nodes. Here you can see worker node 1, worker node 2. So the master node will be called as the Kubernetes master or the control plane. Other nodes which actually take the load are called worker nodes. See, this is the master node or the control plane. Other nodes are called as worker nodes, right? Or else they are called as minions earlier, but now they were called as worker nodes or simply Kubernetes node. Kubernetes node means it's a worker node. And in Swarm, if you remember, we can also put the load on master, right? But here we will not put any load on the master, strictly only on the worker nodes. Of course, if you want, you can put the load on master, but we'll never do it in Kubernetes. Okay. So, um, this is the worker node, like we are having two worker nodes and one master node or the control plane of the cluster. That's called control plane because master is the decision maker, which makes all the decisions of where to deploy the containers and all. So before going into the master, let's talk about the different components in the worker node. Right here, you can see the first component is Docker. Do you see that? See, we run the deployments here, right? So you need to have Docker runtime on every machine. See, on every worker node, you have Docker, the container runtime on every machine, right? Like if you want to run Rocket containers, you have to install Rocket. That's the first component which exists on every node. Then second comes a component called kubelet. What is this kubelet? Kubelet is nothing but the Kubernetes agent running on the worker node. Means on every worker node, we need to have an agent running called kubelet. Means if you see here, the master node means the components in the master node will be giving the instructions to these worker nodes, like where to start a container and all via this component called kubelet. Right? Kubelet is the component which will have all these components. Right? So that's a kubelet, which will take instructions or which is a Kubernetes agent running on every master node. This is important because master node components interact with kubelet to give any instructions to start a worker node on which environment and all. So, yeah, that's a second component. Then comes another component called kubeproxy. What is this kubeproxy? See, how do containers on different nodes communicate? How do different nodes communicate? How do containers on different nodes communicate? All of this network communication, or else how do you access the application to external world? All this kind of communication will be taken care by this kubeproxy. Kubeproxy is a component, network component, which will take care of all the communication across the cluster, right? And here, if you see, kubeproxy is called as the network brains of the cluster. Okay, those are the first three components. Clear with these three components? Any questions here?
Pretty, this kubelet is kind of command line, we can say.
Not a command line. It's a component. It's a tool which we should be running on every worker node. It's an executable which runs on every worker node.
Okay, so control plane sends instructions or commands to kubelet, and then kubelet executes it on uh, pods, something like this, right? Here.
Yeah.
Okay.
The next component is called a pod. You can see these are the pods. Okay, what are these pods actually? What is a pod? See, in Kubernetes, you will never see a container like this. What is meant by this? You will never see container deployed in the cluster like this. Always, a container would be wrapped around a layer called pod. Always, it would be wrapped around a layer called pod. Containers would be always wrapped around a layer called pod. Every pod will have the network interface and every pod will be having some IP address, right? The container running inside the pod means a container running inside the pod will share the same pod network interface, same pod IP and so on. To access this container, you will use the same pod IP. Like I said, every pod will have an IP. Container will not have an IP. Okay, pod will get an IP. If you want to access this container, pod IP, some port number. Right, container will share the same pod network interface, same pod IP. Container, this pod works like a wrapper for this container. It is like a home for the container to live. Always containers would be wrapped around a layer called pod. Right, pod is the basic or the fundamental unit of deployment in Kubernetes. Means you always deploy the pods, you scale the pods, you delete the pods, you work with the pods, you never work directly with the container, right? Like it's like a wrapper, a layer above your container. So what is the importance of this layer? Why should it have this pod layer? Why should a container have this kind of pod layer? Anyone, any guess, any idea? Why do you think it needs this layer? See, pod, like I said, it's a having a container, right? And this pod layer works like a layer of abstraction. Actually, this is a pod. Inside this, you can have any number of containers, but the general practice or the best practice is one container per pod, right? This pod works like a layer of abstraction. What is this layer of abstraction? See, we understood in the beginning, Kubernetes allows containers from any runtime. It may be a Docker container, it might be a Rocket container, it might be a Creo, whatever. It might be containers from any runtime. Irrespective of the Docker runtime, you deal with the pod the same way, right? You don't need to learn how this container works and all. You just work or deals with the pod in the same way. This is the kind of layer of abstraction you get with this pod. That's the importance of pod layer, right? So that is the importance of pod. Now these are the four components like the Docker, kubelet, kubeproxy, and pods. Like they're nothing but see, whenever I say a pod, you can understand it's a container with a wrapper. That's all, right? We never say deploy the containers or delete the containers. We don't use this terminology in Kubernetes. You have to say it's a pod. Pod is running, pod status, pod failure. This is how we deal with. So whenever we talk about a pod, you have to understand it's a container with a wrapper. So these are the components on the worker nodes. Now that we understood the components on the worker nodes, let's go through the components of the control plane, like API server, that's the first component, scheduler, controller manager, HCD. So these are all the different components you have on the control plane. Master node is called the control plane of the cluster, as it's a decision maker, as it is the most important part of the cluster. So that's called as the control plane. First component is API server. That's called the core component, or else you can consider this like a brain of the cluster, right? So what it does, how it works, let's see. See, like whatever, like let's suppose you want to deploy some pods in your cluster, you want to deploy some like 4 pods or whatever, you have some specifications or configurations, right? You define them in a manifest file. It could be in YAML or JSON. We use YAML in our course, and that's what we use more widely. So you define your expected state or desired state of your cluster here. And you put this, or you run this manifest file, means it is fed to the API server. API server will be the entry point to the cluster. You run this means you fed this to API server, right? See, through CLI means through command line you can do this. Kubernetes has also got user interface. Through user interface you can do it, but user interface is not very famous. You should learn CLI for sure. So you fed this to the API server. API server will validate your manifest file. It will understand, it will validate. Once it validates your manifest file, it will give instructions or send the instructions to the scheduler. Means API server will approve and validate, but it will not do the actual task. It will inform the scheduler. Scheduler, as the name says, it starts the pods on the worker nodes, means on which node a pod should be started at what time. This kind of scheduling would be done by the scheduler. Means pod should be started on worker node 1 or worker node 2. Which pod should be started at on which node at what time. This kind of thing will be handled by the scheduler. Am I making sense? So scheduler will do this, but how does scheduler does this? Scheduler will interact with the kubelet and sends the instructions, like when a container, when a pod should be started on which node at what time. These kind of instructions would be taken care or sent by the scheduler, right? Then comes the next component called controller manager. Controller manager, as the name says, it will have so many controllers, like endpoint controllers, application controllers, node controllers, pod controllers, and so on. Means it is basically which is like a watchdog. This controller manager will be like a watchdog, which will be watching all the, or else which will be monitoring all the pods in the cluster. It runs some watch loops, unending watch loops. Unending or non-terminating means continuous watch loops, which will watch this desired state versus the actual state in the cluster. Actual state means, yeah, as per the desired state defined in the manifest, you say you want 4 pods, but actually let's say there were only 3 pods running, right? 3 pods in the cluster, that's actual state. So it will be running some watch loops which compares these two, desired and actual. Okay, when there is a difference, means yes, it should start a new pod, right? So it will run the watch loops, and whenever it notices the difference, it will send again the instructions to the scheduler, because scheduler has to schedule it, right? Again, like a new pod, it has to schedule. So it will send the instructions to scheduler. Scheduler will again send them to kubelet. Kubelet will start a pod on the defined node, whether it's on worker node or worker. So this is how these 3 components interact to perform the task. API server will validate your manifest file and it will give instructions to scheduler. Scheduler has intelligence to see, like to calculate the resources on worker node, worker 2, like which node has got what resources, on which node it should deploy the pod at what time. This kind of calculation or intelligence scheduler has got, right? The scheduler can give instructions to kubelet to do this, but that's the first, when it is for the first time. Next time controller manager keep on watching it, and any modifications or anything went wrong, it would again send instructions to scheduler. Scheduler will use its mechanism to calculate the available resources and the pod resources, and it puts the pod on the right node. All of this would be taken care by this control plane. Am I clear? Understood first three components: API server, scheduler, controller manager.
It's something new, so difficult to understand, but concept is going to be clear. And Priti, what do we name this YAML or JSON file? Like in Jenkins, we call Jenkins file, Docker files.
No name, you just call us Kubernetes files or Kubernetes manifest.
Okay.
Any questions from anyone? Any component you have confusion, please let me know. Understood all the components, what API server does, what scheduler does, what controller manager does. Okay. So now that we understood the three components, let's come to the fourth component, HCD. HCD is called the, like API server, we call it as a brain of the cluster. HCD would be called as a memory of the cluster. See, till now we understood like, okay, API server is validating, sending the instructions to scheduler. Scheduler will interact with controller manager and do the deployments, right? But how does all of them gets the information of the worker nodes? Like, what is the actual status? See, it's comparing expected versus actual. How does controller manager know the actual state? Right? Or else how does controller manager know the desired state? Or else how does scheduler know which node is having what are the left, like what are the remaining resources or available resources? How does they know? If scheduler is given the resources available, it can calculate and decide on which node it could deploy. But how does it know the resources, available resources, or consume the resources of these nodes and so on? All that information of the cluster will be stored in HCD. HCD is like a NoSQL database where data will be stored in the form of key valued pairs. Right? So HCD, that's why HCD is called considered like a memory of the cluster. All the components gets, all other components like scheduler, controller manager gets the information from this HCD and proceeds with the next stage of decision making or deployments and so on. So HCD, that's why HCD is called as a memory of the cluster, as it has got all the information of your cluster configurations. So these are the different components you have now. Every component is very important. And when you install the cluster from the scratch, yes, you need to take care of these components as well. So a total different architecture from Swarm, right? Swarm architecture is very simple. You have so many moving components here. But yes, that's how the Kubernetes architecture is. Like I said, it's a far advanced tool. Out of all the tools in our course, this is far advanced and people feel it a complex. But if you learn it properly, you will enjoy working with Kubernetes. Kubernetes alone can fetch you a job. Remind that. So, got it clear, right? So let us talk about the setup now. Kubernetes cluster setup. Kubernetes cluster setup can be done in multiple ways. There might be on-prem servers or physical servers, right? Their own servers where you have to do the setup, on-prem kind of setup, on-prem setup. Like they may have their own servers or virtual machines. On that you have to set up the cluster, or else you have to do it on Google Cloud Platform, or else on AWS. or else on Azure, whatever cloud. Okay, there are so many other clouds, DigitalOcean, Linode, and so on. Whatever it is, I'm writing 3 clouds and on-prem. So if you are doing it on-prem, right, you have to take care of single component, each single component, like you have etcd, you have APIs, or everything you have to configure manually, right? That's a very raw way of doing the setup, which would be definitely very complex. To make these kind of setup simple, you have got a tool called kubeadm. Kubeadm is a utility or a tool which can help you manage your cluster. Means manage your cluster in sense, let's say create your cluster. Kubeadm is a tool which can help you create your clusters, right? Create a Kubernetes cluster and connect or communicate with them. So that's a kubeadm tool which can help you here. So that's one method of doing it. Of course, first you have to learn this kubeadm method. Raw method, you don't need it. Kubeadm method, if you know, you'll get more clarity on how you create master nodes, worker nodes, and all. Then you can do it on any cloud platform. So now if you talk about GCP, Google Cloud Platform, it offers a service called GKE, means Google Kubernetes Engine. Okay, this Google Kubernetes Engine is a service on GCP which comes like a pre-package, with a single click you can create a cluster. Just a single click you can create a Kubernetes cluster, that to a production grade cluster, absolutely free. This service is offered by GCP because if you remember, Kubernetes is basically a product of Google, right? So GCP offers you with this service. So if you want to learn this, yes, you can go and use this GKE service, everything for free, you can learn it, right? Production grade cluster, you can learn here. Now, coming to AWS, there are different ways you can set up the cluster on AWS. There is something like Kubernetes operations. Using this, you can do the setup, or else the best way is EKS, Elastic Kubernetes Service, which is equivalent to GKE. Okay, this is a managed service, a paid service, but a production grade cluster you can create. And believe me, this EKS, like majority of the Kubernetes clusters, or else 60% of the Kubernetes clusters or EKS clusters. You can imagine how famous it is, how widely it is used. It's paid service, it's a paid service, and you can create a production grade cluster completely free. Sorry, I'm sorry, so sorry. A production grade cluster you can create, but it's a paid service, right? Then comes Azure, like any cloud provider, if you take. So like I'm saying from the beginning, you don't need to learn all the clouds. You don't need to learn GCP, then go Azure, then AWS. No, you will learn one cloud. You can use other clouds very easily because services would be similar. Analogy would be similar. Like you have GKE on GCP, EKS on AWS, you have AKS on Azure, Azure Kubernetes Service. So yeah, they were all similar. So if you learn one cloud service, means one Kubernetes service on cloud, that would be enough. So in this course, first I'll get started with kubeadm, because if you do kubeadm, you know what is cluster, how you create, so that you can understand any other clusters. So first we'll start with kubeadm cluster. We don't have physical servers or our own virtual machine. So what we'll do, I'll use some EC2 instances. Okay, but we'll consider them like a virtual machines or physical servers, because I'll not use any AWS services like the COPS or EKS here. Without using any of them, I'll create a cluster in the raw method, assuming they are just VMs or the physical servers, right? So that's the first setup we'll do. So yes, using this kubeadm, you can explore all the features, right? In real time, it is also production grade cluster. You can use all the features, but with our lab setup, we have certain limitations. You can't explore all the features. Okay, that is one reason. Also, I would like to show you EKS because that's how we work in reality. So I'll also go with the EKS service and we'll show you whatever features missing here. We'll learn them here. Of course, see, remember in real time, you don't miss any features here. You can explore all the features. But with the kind of our setup, because we are doing with EC2 instances, certain features we may not explore. Those we'll explore here on EKS, and also the advanced things like automatic scaling and all, I'll show you on EKS. See, whether you create the cluster with kubeadm or with a GKE or AKS, setup is different. That's all. But one setup is done. The concepts, the commands, the Kubernetes manifest files, everything is same. Okay. So we will also go through this EKS. So EKS is a paid service. You can just watch it. Only the features we miss here, we'll do it here. So if you watch it also fine. If you are interested, you can go for it. It's up to you. But I'll show you both of this. If you know EKS, you can work with GKE or any other service very easily. So this is the plan. Any questions here?
No, Preeti, all good.
All right. So now let's begin with the setup. Here, like I said, we'll get with the kubeadm setup. Kubeadm is a utility with which you can create, with which you can manage your Kubernetes clusters. So for this, we need some virtual machines or a physical server, right? I don't want to create any virtual machines on my laptop. Rather, I would use EC2 instances. So let's create some instances and do it. Here, I'm going to create a 2-node cluster. Okay, a 2-node cluster, one would be acting as a Kubernetes master, other one would be acting as a Kubernetes worker node. So let us begin. Good to go?
Yes.
Yes.
Let us get started.
For this also, we are going to use that address book and all that project, Preeti.
We will deploy, we have to make the deployments, right? Then we'll use them. First, initially, we deploy the pods. Pod comes from any image, anything you can deploy.
Okay.
It may be address book or anything.
Yeah, probably I would suggest let's take another project other than address book if we are going to deploy something.
Then how do you do the flow? How do you connect it in the pipeline if you take something else?
Because actually, see, we
CI/CD Docker image is built with the address book. That image you deploy in the cluster. How do you get the connectivity if you do? So you don't want the pipeline?
it's not like that because see, there are something which we are,
Kiran, can we discuss this at the end of the class? Let's not deviate. We are creating the cluster. What to deploy? Let's discuss later. Okay.
okay.
Let me create the notes. I'm going with the Amazon Linux too. You can use Ubuntu or anything as your nodes in the cluster. They should be Linux. Of course, Windows worker nodes are also possible, but that's again a different kind of setup. Different kind in the sense the container runtime, all of that should be handled differently. So Amazon Linux too. Here in Hyderabad region, we have T3.micro, and also I would go with T3.medium because see, for cluster creation, there's a minimum prerequisites. Every worker node should have minimum 2 vCPU and 2 gigs of memory. So this would suit, okay, 2 virtual CPU, 2 gigs. Of course, you can create with T3.micro also. It will throw some errors. You can ignore those errors. I'm sorry, still having some throat problems. Sorry about that. So 2 virtual CPU and 1 GB of memory also you can create, even though it doesn't meet the prerequisite, you can create, it will throw some errors, you can ignore those errors, right? Or else you can go with it. But I'm going with this because in future, as we go by, as we make more deployments, we may need more resources. So I'm going with it. But for your learning, you can also go with this and ignore those errors. How to ignore those errors also, I'll show you. I'm going with the T3 dot medium and the same key like ABCD key. Right. I'm not opening any ports intentionally to show you which ports these servers need. We may have to spend some time there, but that's fine. Let me launch it. If you go to your drive, your Kubernetes folder, you have all the setup there. Let's see my instances. So 2 instances were ready. I'm just naming them as Kubernetes master, Kubernetes worker. Okay. So this is your Kubernetes master. Let us connect to them. This is going to be the master node. Like I have to make this a master node. Let me connect the other one also. Okay, so this is the master node. We can do one thing. See, this is like a host name is showing this, right? I want to put some host name. This is not mandatory, but always a good practice. There's a host name CTL command with which you can change the host name. Set the host name of this machine as master node. Okay, do the same for the worker node also. Change the host name. Per node. Okay, so done. Now again on the master, let's see hosts. So here they should resolve the host names with each other. Means master node should know, means when you say it's a worker node one, this master node should understand which server it is. So in the HC host file, put these entries, first the master node entry and map it to the host name. Like the private IP, because that's about internal communication. So master node's IP and the host name, and then the worker node's IP and the host name. Let me make sure it's correct. This is the name I have given, right? So these two entries in the HC host file of the master. Save it. Here also, go to the same file, HC host, put those entries. Okay, done. So done. So this is one thing. Next thing is it depends. See, operating system specific commands are there. This is a CentOS instance, right? Amazon Linux tool in CentOS or Red Hat based systems. So for such instances, security in Linux will be enabled, which will not allow cluster creation. So disable security in Linux by set enforce to 0. SC in Linux will be disabled. See, SC Linux means security in Linux will be disabled. Do the same here also. Done. These are the few things. After these few things, the host name should be updated. The configurations you have done should be updated. So reboot, restart the systems. Let's wait for a couple of minutes.
Preeti, disabling the security. So we'll be doing this in real time as well, is it?
Yes, because see, these nodes have to communicate. We don't need SC enable here. We'll take other security measures through firewall and all. So we don't need this.
But disable security measures are like what exactly those are, or what are we disabling inside the security?
Only in these machines we have to disable. That too, like particularly not the other machines, for cloud machines. For cloud machines, it is enabled by default. See, if you see, host name got updated. Do you see here? Right? To identify them properly, we have got the host names updated. Right? That's all we have to do. Now you can install Kubernetes. Here we'll be installing components like kubeadm, Cubectl. Okay, first let me write kubelet, Cubectl. What is kubeadm? Kubeadm is a command line utility with which you can create or manage your clusters. Like, let's say there are multiple clusters, you want to check some cluster information, you can use kubeadm. Or else if you want to reset cluster configuration or create clusters, all of that can be done by kubeadm. Kubelet, we have learned, right? It is a Kubernetes agent which should be running on every node. That's how your API server will interact with kubelet, with any other nodes. So kubelet should be installed on every node. And also kubectl. Before that, let me say Docker. Docker is a container runtime. Obviously, it should be there on every machine. Right? Then comes the kubectl. Kubectl is the Kubernetes command line utility tool. CLI tool. Right? This kubectl is the way with which you make the deployments, with which you scale the deployments, with which you create services. Anything means to interact with the cluster, you use this kubectl. You may be creating your cluster on-prem or on any cloud. Kubectl is mandatory with which you connect with the clusters. Right? So first, let us install all these components. And to install all these components, you have to use yum and all. But yum repository should be there, right? If you just go here, etc yum dot repos dot. See, you don't see any. I mean, you are seeing some repo files, but I want to install this Kubernetes from a separate repository. So I would like to create a Kubernetes repo file with this command, which will have all the Kubernetes repositories. See, cat read till the end of the file and place it into this file. Right, Kubernetes repo is created, and see, these are the URLs from where it can download. Do the same for the other worker node as well. Okay, so as we have configured it, now let us try installing them, and I'm going to install a specific version of them. Okay, install the same version so that it would be compatible with our nodes. Kubelet, kubeadm, kubectl, and of course Docker. Docker 1, 2, 3, 4. All the 4 components, whichever I have listed here. install them on the other node as well, worker node also. You should have all these components. Once these components are installed, let us start Kubelet. Kubelet is a very important component. Start Kubelet, Docker. Also enable them. Enable Kubelet, Docker. So start and enable them on other nodes as well. Okay. So yeah, now that everything is ready, this is the master node, right? I want to make this as a master node. Now comes the difference. Till now everything is same. Now we'll create a cluster using the command kubeadm init. Kubeadm init will initialize the cluster and then API server advertise. You have seen similar command in Swarm, right? Advertise address of your master node. Master node's private IP. This one. Right? So that you will start the cluster. But also you can do one more thing. Pod network CIDR. What is CIDR? CIDR range is the network range. CIDR full form is classless internet domain routing. Right? You will create the pods, right? Pods are nothing but containers with the wrappers. They'll have the IP address. So what is the network range IP address should be assigned to it, right? So there's a default network range you can assign, or else if you are creating your own network, you can put this is the default network range. I'm leaving them as is, right? So when you run that, it will create a cluster. But if you are using less CPU and memory than the prerequisites, you can ignore those errors using ignore pre-flight errors, number of CPU and memory. You can do that, but so that you can use smaller instances also and create the cluster. But I am creating a cluster with a 2 CPU, 2 vCPU and 4 gigs of memory. So it should not give me any error. I can run this one. If you want, you can ignore them using that. Ignore pre-flight errors. Let it finish. A cluster should be started in few minutes. So here you can see control plane has initialized. See, if you see it has creating the Cube API server, controller manager, scheduler. Kubeadm is taking care of all of that. Starting the kubelet, right? It has done all of that. And master node is created successfully. Okay, and yeah, control plane has initialized successfully. To start using cluster, you need to run as a following user. See, I have created a cluster as root user, but always you will not have root user privileges. You should be starting your cluster as regular user or any other. See, this is my master node. It's not always that you jump onto your master and run these commands. You will never log into your cluster. You will connect to the cluster from outside. How to do that also I'll show you, but that's how you do. You don't need to log into your master node. Okay. So to run as a regular any other user, here there will be file called, let me show you. Go to whenever you create a cluster as a root, etc Kubernetes. See, there is a file called admin.conf. This is having all the cluster configurations or else cluster authorization, like how to connect to the cluster. So if any other user have to connect to this cluster means they need to have those commands, right? That was the command it was showing to run as a regular user to connect, right? Let us do that first. Also the token, I did not copy the token. We'll get the token. First, let me do it as a regular user. Let me switch to, or else first let's get the token. How do you get the token? Kubernetes, sorry. Kubeadm. You can copy the token. It was giving you the token, right? Or else you can also list the tokens. Kubernetes token list. Yeah. Okay, this has given you a token. But this is not the one. You can do one thing. Kubernetes token create print join command also we need to join, right? This is the one. So let's first do this. Let's take this and run it on any other worker node, whichever you want to connect. So I want this worker node to be connected to the cluster, run this token. Let's run the token. Kubeadm join. There will be an error because see, it was trying to connect through the port 6443. If this port is not open, it will throw you a timeout error. On the master node, this port should be open for other worker nodes to connect. Let it finish first. Meanwhile, let's do one thing. Let's come here. So now let's connect as a regular user. Okay, see, I become a city user. So whichever user you want to connect, you have to create a file called kubeconfig file. Means you should create a directory called .cube in the home directory. See .cube, and you have to copy that admin.conf into this kubeconfig. That's called kubeconfig file. Kubeconfig means .cube folder config file. Provide the permissions. Right now, as I have placed this kubeconfig file here, EC2 user can get the information of the cluster. Kubectl, get nodes. See, only one node, control plane. Other node is not yet added. Let's see here. See, it was still checking on it. Let's wait. So one node is ready. We can do one thing. Run with the okay minus v5 with a verbose. See here it paused. Do you see here? Requesting information on this port because this port is not open. right? It has checked everything else and failed to request the cluster timeout exceeded while waiting for the headers, right? Because that port on this master node is not open. So let's go to the master node, go to the security. That is the port actually where API server will be running. Okay, so go to this launch wizard 11. Inbound rules, edit the inbound rules, add a rule 6443 from anywhere. Save the rule. Now
It is
let's
only
go.
the specific port, or we can add any port there?
6443. It was trying on 6443 is the port, not any port. It is
Every time it will be same.
same port, API
Okay.
server port.
Okay.
See, now that after doing it, initially it failed, then it was successful after once we added that port in the security inbound rules, right? So now finally worker node is ready. It was saying, yes, this node has joined the cluster. So now let's go here and check that. Yes. Do you see the worker node got added? You can see here, right? It is added, but status is not ready because we need to do one more thing here. See, it is ready, but all the networking will be taken care by kubeproxy, and you have to install some network plugins. There were different network plugins like Calico plugin, Flannel plugin, and all. Default official YAML manifest files were there, so deploy them. That's what I'm doing here. Kubectl apply -f that file name. You will see this command very frequently once we start deployments. So for now, just consider we were deploying some manifest files, which will deploy the Calico network plugin. See, you can see here Calico node created, right? Calico deployments were done. If you want to see, I'll show you. Give me a second. First, get the nodes. In few minutes, they should be in ready status. Meanwhile, see, I have created API server. I have created so many things, right? Like etcd, controller node, controller manager, all of them. All of them, if you want to see, get pods means get PO -a means all the pods. See, Calico network plugins, the core DNS pods, which are mandatory for the cluster, etcd, API server, controller manager, kubeproxy, scheduler. Do you see all the components? Yeah. Calico is ready and the nodes should be ready. Yes. Understood, everyone? Nowadays, companies, particularly mid-sized companies, startups, they were preferring to move their infrastructure to on-prem. The reason being, yes, EKS is very efficient. You can create production-grade clusters. It works very well, but because of the cost, they may not be able to afford that cost, or else to balance that cost. They were looking for the clusters to, they were moving the clusters to on-prem. So you should also have good understanding on the cluster creation on-prem this way using kubeadm. This is the hardest way of creating the cluster. Easiest way is using cloud providers. GK is very easy, first easiest way. Then EKS is not that easy, but of course better than this. Managing the cluster, maintaining the cluster, creating the cluster with kubeadm is the hardest way. Other ways, managing your cluster becomes super easy with cloud provider services like EKS, GKE, and so on. Because they take care of all the management of the cluster, particularly the control plane. Master node should be highly available. So these managed services on AWS and Azure, they take responsibility of providing high availability of the control planes. They'll take all the management of the cluster. That's why we prefer cloud services, but yeah, they were costly. So if certain companies, organizations, if they can't afford, they may go with the kubeadm, but definitely they need a strong resource to do this kind of setup. Here, because it's a two node, it might be simple. And also here, these are again not a physical server, so the setup might be simple, a bit simple. But in like on physical servers, the network configurations may be different. It all depends on the OS, the network configurations, or that particular network configurations, right? Every company may have different network configs and all. But on the whole, these are the major steps. So yeah, finally, cluster is ready. All the default pods, like the system pods, we can see, right? Like network plugins, HCD, Cube APS, or everything is running perfect. Cluster is ready. Like I said, right? You don't have to jump onto worker node, or you don't have to jump into master node and run these commands. What we'll do is, this is your cluster. See, this is so this is your cluster, 2-node cluster. You can connect to this cluster from your laptop. Yes, that is possible. Or else you can also connect to it from outside, like create another EC2 instance, or there'll be something like Bastion servers, a jump server kind of, with which you can connect. That's how we connect. But for now, we are onto it. But I'll also show you connecting from outside when we go to EKS. For now, yeah, we can continue with this. But understand, yeah, you can connect from outside and do all these configurations or deployments. So cluster is set up, and if you see get pods in the default namespace, means namespace is to categorize your applications, your deployments. It's like grouping. Okay, whatever we have seen, -a means pods of all namespaces. This is a default namespace, system namespace, cube system. Everything is there. Now, if you want to deploy your own application, okay, you can deploy in the default namespace, or you can create your own namespace. For now, get PO means it will show pods in default namespace, no pods. Let us deploy the pods in the default namespace. Please keep muted everyone if you don't have any questions. Now let's create a pod. How to create a pod? Like I said, we'll use YAML.json. Declarative approach is the preferred approach. You may give any name to your manifest file. I'm giving pod.yml. How to write this manifest file? See, people worry about how to write this manifest files. How should I know coding? This is not coding. Do you call this coding? Let me show you. This is the Kubernetes official documentation. Okay, this is the preferred approach. This is how you write the manifest files. Of course, as years pass by, you may just writing it on your own because everything will be on your fingertips, or else you can always refer this official documentation in your projects also. It will be allowed. It should be allowed. In the interviews also, it should be allowed. Right, because official documentation is the reference which we use for Kubernetes. In interviews also, if they ask you to write a manifest, you can use it as well, right? Particularly in certifications also, this is allowed, right? So that's an open book exam for Kubernetes. In work environment or interviews also you can use, because you don't need to learn writing the entire manifest file. Okay, so just search with the pod. See, here is the manifest file. Just copy and modify it accordingly. And sometimes people say this is coding, there is a lot of coding, I don't want coding. Is this a coding? Any logic we have written? It's just what I call it as a template. You modify the template, take the template and modify the template. So this is not coding, definitely. If you are still under the impression this is coding, definitely not. You put your own image name and all. Okay, anyway, let me explain you each parameter first. The first comes API version. There's few attributes are mandatory. API server, kind, metadata specification. See, in Kubernetes, we create so many objects. The first object is pod object. Okay, every object will have 4 mandatory attributes. Like API version, kind, metadata, specification, spec. Remember, these 4 should be mandatory when you write any object. as you go by, as you keep on using them for years, you can write everything on your own. But still, if you don't want to write, let's say I'm very lazy, I don't want to write, I can fetch that from the Kubernetes official document. There's no wrong in it. Okay. So first mandatory option is API version, which means the version of Kubernetes API. Kubernetes is an API. So V1 kind tells you which kind of deployment or which kind of object you want to create. Okay, that's a pod. Then comes metadata. Metadata means it gives information of the object you are deploying. Like, let's say I want to give the name as sample pod. Any name of your choice. Okay, if you want, you can also give the labels for your deployment. Labels are like tags. Okay, labels will have again some label name, app, sample app, something like that, like tags to identify your pod. Name, labels, all of that goes into metadata. Then what is specification? Specification is about what is inside that object. What is our object? What is our object here? I'll wait for your response. If no one is listening and no one wants to talk, how do I proceed? What is the object we are creating now?
Pod, right?
Pod.
We are
Pod.
creating.
So the pod is our object. So metadata gives you information about your object, like name, like labels. Labels are like tags. They're quite powerful. They're very important. We'll see their importance later. But pod is the object. Metadata gives the information of the object. Specification tells you what is inside that object. That's how you remember. See, later on, I see people struggling understand what is this one, what is this one. They don't understand the meaning of it. They blindly go through it, which makes things very difficult. At the basic level, I'm teaching you this. Please concentrate and understand and let me know if you don't understand something. This is easy way to memorize the things. Metadata gives you information of the object. Information of the object. Information of the object. Kind tells you type of object. It's a pod. In this case, it's a pod. API version is the version. It's very clear. Specification is what is inside the object. Understood, everyone? Later on, I'll not repeat these things. I'll just straight away write API version, kind, metadata, spec, and proceed.
One
So,
query.
tell me.
We have given kind, okay? Kind
Mm.
means we are declaring the object. Every time it will
Type
be the
of the
pod.
object.
Yeah, type of the object. So it will every time it will be the pod, right?
Why every time it will be pod? There are so many objects. We'll be learning them.
Okay.
Okay, basic object is pod. There were so many objects. Why do you need those objects? What are those objects? We'll learn that. So many are there. Pod object, deployment is another object, service object, config maps, secrets, PVCs, PVs, daemon sets, so on, so many are there. Okay, we are getting started with pod, that's all.
Okay.
That's why type of object kind tells you what are you going to deploy. Is it a PV or PVC or secret? What is it? Okay, so that's a type. Information of the object is metadata. Specification is what is inside it. Now, what is inside the pod?
We are creating container.
We have containers. In the architecture, we have learned, yes, containers are there inside the pod, right? Okay, so that's what is a container inside the pod. Now, specification gives you information about what is inside, like name of your container. I will give, let's say, sample container. Then, see, how is container created? How do you get a container? From an
Docker.
image, is it? Image, yes, from image. So deploy v1 or whatever image of your choice, you put your image. Then your application will be running on some port, right? That's called container port. Application runs on 80. That's the application port. Is nothing but the container port. That's what is defined here. Now, can you understand the YAML file?
Yes.
Any questions in the YAML file? Manifest files are very simple in Kubernetes. It's mandatory. You should understand them. You don't need to write them from the scratch, but you should understand each attribute here.
Preeti, here
I
we
would-
we not mention the containers are from Docker or some other.
One second. Tell me, please.
Now, if this container is from some other service other than Docker, do we need to mention here somewhere?
You mean other container runtimes? See, by
Yeah.
default, the container runtime is Docker, so we don't need to mention it. If it is any other container runtime, you have to configure that runtime, right? We have installed Docker here. You have to
Okay.
install that container runtime. Okay,
Okay,
but
so
majority of the times, most of the times, it's going to be Docker.
now
Tell me.
my query, like if I'm running two containers in the same machine, that is possible. In that
Two?
case, do we need to mention here, like two containers, maybe
Two.
Docker and some other container service?
No, any one runtime at a time, not both at the same time.
Okay.
You are running here Docker runtime, that's all. If you want to put Rocket, uninstall Docker, put Rocket. Only one
Oh.
runtime at a time, not both of the time parallelly.
Okay, got it. Thank you.
I would be deploying some container like this. I have, some image. I have deploy repository, V1 is the image, and it is also running on port 80. That's all. So if I run this, it will create a pod with a sample pod, sample app label, sample container name from this image. One pod will be created on the available worker nodes. How many worker nodes I have?
One
One.
worker node as of now.
One worker node. So it will go to that node only because there is only one worker node. So let me save this file. Now apply the file. Cubectl create if you are doing it for the first time. Pod.yml -f file name. That's how you run the file. See, pod is created. Kubectl get po or get pod. See, it's still in container creating state. Do you see that?
Yes.
If you want, see, now it went to running. Do you notice the status? Also, if you want to see more details, describe pod, right? Let me clear off this. See, this is important. When you describe, events are there. In the beginning, I told you in the architecture, right? Kubelet. See, default scheduler will get the successfully, it has assigned it to worker node. It has given information to Kubelet. Kubelet is the one responsible to download the Docker image, pulled that image, then created a container. Kubelet is the one which is responsible by taking the instructions from the scheduler, right? So events tells you everything. When it happened, 21 seconds back, 12 seconds back, container is started. And if you scroll up, you will see the name of the pod, namespace, the IP address. Like I told you, every pod will get the, sorry, this is node IP. This is pod IP. Every pod will get the IP address. If you remember, we have given some pod CIDR range. So IP address will be assigned from that range. Every pod will get its own IP. This is on worker node 1 because anyway, we have only one worker node. It will go there only. And it's the IP of the worker node, pod IP, the image from where it was running, the state, everything. Conditions, like it was all ready. So it was all true, right? So this is your pod, and that's how you can describe it. And if you want to see where it is running with output wide, clearly you can say IP of the pod, the node where it was running, right? Simple way of deploying a sample thing, like a basic deployment. But now let's say I want to run 100 pods. How to do that? I want to scale them. Or else, okay, it's running, but still it's not exposed outside, right? Application is not accessible from outside. How to do that? How to expose the application to external world? How to scale these pods? Let's say I want to run 100. Should I write this 100 times? So how to scale them, how to expose the application to external world, how to upgrade. I want to implement rolling updates, rollbacks. How are all of that possible? This is the very basic way of deployment through the kind pod. If you do this kind of deployment, you cannot achieve all those advanced features. You can achieve, but very complex. So to support all that advanced features, there comes another REST object in Kubernetes API. Kubernetes is an API. It has got different object. The next advanced object is called deployment object. Like you have kind pod, you have kind deployment. If you do this way, yes, you can achieve scaling, you can achieve rolling updates, rollbacks, upgrading and all. So this is the best method and the advanced approach used in real time. So let's not deploy pod like this with a kind pod. Let's deploy deployment. What are the other advantages? What happens at the back end? How it allows all these features? We will study tomorrow. This is fine. I'm not saying this is not correct. This is correct, but very basic way. To achieve all those advanced features, we have to change the kind to deployment. We shall take up from here in the next class. So any questions in this part from anyone?
Priti, in this image, you have mentioned DevOps trainer / deploy :v1, right? So how does it fetching these details? This image,
Docker pull is happening. How is Docker pull happening? We learned Docker pull, if you remember, the image name and all. So how is it fetching the details? How does it know DevOps trainer and all?
It is from the Docker repository.
The same way. What is the difference? Docker is a container runtime. It was pulling this image like Docker pull is happening.
Okay, Kubelet is pulling that image. Okay.
Kubelet is not pulling. Kubelet will allow Docker to pull. Kubelet is responsible for all of these activities. At the backend, again, Docker will be there. Those are Docker containers, Docker runtime. It will image name tells you everything, the registry, the repository, username, everything. No registry means it considers as Docker Hub. Go to this username. Docker pull. You might have learned Docker pull by now.
Yes.
So the same.
Okay, now I got it. In the beginning, we have already installed the Docker in this machine, and that's why it is taking this command.
Yes.
Okay.
Yeah. The Docker runtime is there, which will take care of that.
All right.
Preeti, what will happen if master node is corrupted or down?
Sorry?
Maybe the master node may corrupt or down, right? For some reason. So what will happen to this existing pods?
Master node, if master node goes down, entire cluster will go down. So you have to maintain multiple masters. Like we have created one master, you have to create two masters.
Okay.
So that if one master goes down, another master means you should be always taking care of high availability of those masters. That's the challenge with this kind of on-prem setup. That's where cloud services comes in. In cloud, you don't need to take care of it. Cloud service, EKS will take care of it. That's the challenge here.
And what about the backend volumes, Preeti? Like we have multiple pods, right?
Backend?
Volumes. Maybe the data will store on one volume, right?
Volumes also we will create. We will do that also. We'll deploy address book. We'll also deploy PHPDB. We'll see volumes, everything we will see.
Okay, fine.
Like we have seen volumes for our database, here also you have volumes. Oh, if you're talking about volume backup on these servers.
Yeah, because we have multiple pods and all, right? So the volume should save in one location, right?
Yes, volume backup. Yeah, those are all the challenge you have with on-prem. When you create volumes, you can have backup of your volumes as well. There were separate tools, add-ons for Kubernetes, which will take care of those backup of your volumes like Kten and so on. Different tools are there, third-party tools for backing up of those. Or else you can connect it to a remote storage like EFS or else any other remote storage on cloud or another physical server to have backup of those volumes.
Okay.
These are all the challenges you have with the on-prem. That's the main challenge or drawbacks you have. Maintenance, lot of maintenance you have. There will be a separate team in such cases to manage those things. So go through the session, get your setup, a cluster setup ready, right? And we'll take up from here in the next session.
Pretty commands are there on document, right?
Yes, in your drive, you have everything. This is the documentation on the drive, on your folder. You have all the cluster setup commands and the pod also. Next document you have for pod.
Sure.
Do it carefully. Okay, step by step, do it very carefully. If you mess up again, troubleshooting, you will lose a lot of time. Initially, don't concentrate on troubleshoot because first you have to do the setup and learn it. Later on, you go for troubleshooting. Troubleshooting is very important, but initially, if you just concentrate or sit with that part, you will be stucking up there and you'll miss the other hands-on. So get your setup ready quickly and get started with the hands-on. All right then. Thanks everyone. See you tomorrow. Bye everyone.
Every-
Thank you.